Okay, so right now let's get into data structure. Data structure. So data structure is different from data types. Data types are the basic forms of data, okay? While data structure are the ways in which these data are structured, are arranged, are compacted. I hope you know that now. Okay, so there are like five basic data structures in R. The one is vector. We have dealt a lot with vector. That vector is what? Is a variable of one or more values of the same type. The same type. They have to be the same type, okay? If you remember our integer here, this is a vector where the name is a variable and it contains numbers or values of the same type. Is that okay? So that is what a vector is. In real sense, all this work that we have created, they are vectors of different types. Now, vector of integer, vector of numeric data, vector of strings, and then vector of logical data. Do you understand that? So the second one is data frame. Data frame. Now, this data frame is actually like a typical example of a data frame is your data set when it is brought into R and you view it. It contains rows and columns with their respective names, all right, with their respective um, names. For example, flower, flower, or flower to anyone you want to say, this is a typical example of data frame. Is that okay? It has what? Rows and it has columns, which is the different names for the different variables, different vectors, and the rows are the values of these vectors. Now, if we bring in a data frame, if we bring in a data and we want to view the class of this flower, it will tell us it's a data frame because it's more than one data. It's complex than a vector. Just look at it. Flower. What does it give? You say it's a data frame. And if you want to get more information about data frame, just put data dot frame. R tells you the function data frame creates data frames tightly coupled collections of variables which share many of the properties of matrix and of list used in fundamental data structure. So it's what tightly coupled collections of variables. These are the different variables that we have created here. If you look at flower2, class flower2, we included other variables like names and serial number. It is also data frame. Is that okay? So you should not confuse data types and data structure. Okay. So in this data frame, we can even check the structure of the data frame. If we have str structure flower2, check the structure of the data frame. Now it tells you if you are checking the structure of the data frame, now you are looking into the individual vectors or variables in that data frame. Now here it says the name of the data, the class of the data, it's a data frame that has 150 observation, that is 150 rows, and has 7 variables. It had 5 variables initially, but we added a serial number and name, and then now we have 7 variables. Okay. Now serial number is an integer, sepal length, all of this numeric, factor, species is a factor. Okay, species is a factor, name is a character. Now I need to tell you something. the difference between a factor and a character. That brings us to the third data structure, okay, which is called factor. R recognizes a particular data as a factor when it has ordinal or nominal character. All right. Ordinal is categories that have order. A nominal data has categories but doesn't have like order. For example, you have a male or a female, a girl, a woman. Those are nominal data, nominal variables. When you talk about ordinal, it means they have categories and they have ordering or some kind of magnitude attached to them, but not magnitude derived from values. So here you have ordinal. Example, you have low, you have middle, you have high. That is an ordinal, a category with order. You get that now? It has order. So when you have this kind of stuff, R considers them as factor in a data frame. But you will also ask me, but species is not ordinal, but it's still considering it as a factor. Yes, this data has been prepared, okay? It comes with R. There is always an interconversion between factor and character. Any data that has category that are not values, but they are characters and have categories, R will usually consider them as factors. If they are not factors, they are not considered as factors, you will really want to convert them into factors before you carry out your analysis. So sometimes the data comes, it recognizes it as a factor, and that you don't need to change it anymore. Sometimes it recognizes it as a character, but in that case, you need to change it to what? To factor. The next data structure is matrix. Okay, I hope you have an understanding of what matrix is. It's a data of two dimensions. If I put this and I tell R, make a matrix for me, the values should be from 1 to 6, but then I need the number of rows to be 2 and the columns to be 3. It will read it and give me a matrix. One thing you need to note about matrix is that they are also data of the same type, and it is two-dimension. Two-dimension, which means it has rows and it has columns. Okay, so that is matrix for you. The next one is what is called array. Array is just a complex form of matrix. I'll just simply put it that way for you. Data of more than two dimensions. Let me show you what that means, and you can compare that to how a matrix looks. If we have array and we have the same form of data like the matrix, but we tell R this time it should be from 1 to 8 and then give us the dimension. Now you have specified here the dimension to be what? 3. Once the dimension is more than 2, it becomes an array. You run it, it gives you two-dimension data. I mean more than two-dimension data. This first one is two-dimension, rows and columns. This one contains also rows and columns, but two types. So in that case, it's now become three-dimension, no longer two-dimension. If only rows and columns is two-dimension, then you have two of these becomes three-dimension. You can also have four-dimension. Example, if you take this to maybe 12 and you say create another one, it gives you four-dimension, which is what? This is 1 by 1 matrix, 2 by 1 matrix, a 1 by 2 matrix, 2 by 2 matrix. So that is an array for you. This is not very, very important in basic data analysis. I'm just trying to mention this so that you can understand what it is. The last one I will deal with is what is called list. Now, list is simply, as the name implies, contains different data types. Example, if we want to list, let me pick one of these and we can modify so that we can save time. Now, if I have this, I want to make it a list. If we have a numerical variable here and there is an integer, now let's have a character, John, and you have also a logical variable. Now you have different data types. Check the class and you write list. It gives you what? So it's a list, but what it's bringing out here is character. And you know what is happening? This character here prevails and dominates all the other data types. So R will convert all the other data types to a character. And this brings us to what is called data cohesion. R forcefully converts a particular data type into another data, as you see here. Example, you see we have name in that data that we created to be a character. We can change character to a factor as the case may be. And what we all need to do with the function as dot factor, and R gives you, and you have it to be factor. It has changed it to factor, and if we assign a variable like fact and we run it and check the class of fact, you will see that it is now factor. We can also convert species in that data to character. Now let's see, as dot character, and you put this flower and you ask species. Now it has run and you run this. Now you see how it has converted. And when you see this inverted comma already, you know that it's a character. And you want to check the class of SP. It says character. So you can always interconvert between data types in R, but you have to take caution. You have to know when and where to do that. As a last example, if we want to convert petal as dot integer, you have flower and sepalent. Sepalent is a numeric variable, but we can convert it to integer, and it has converted. By integer, R will bring all of them into a whole number for you. Okay, so that is how you differentiate between data type and data structure. I believe you have learned in this lesson. Please practice. If you don't practice, you will not improve. Please, but before you go, share this video, subscribe, and comment, all right, so that we make it interactive. Thank you very much.